Hey everyone, Scott here, and welcome back to Forced Induction TV, where we take the mystery out of car maintenance and performance so you can make smarter decisions in the garage and on the road. Today, we're talking about something that doesn't always get the attention it deserves: brakes. Everyone loves more horsepower, but none of it matters if you can't stop. Brakes don't just slow you down, they decide how much control you really have over your car. And yet, most people buy brake parts based on what's cheapest or looks sporty instead of what works best for their driving style. So today, we're breaking it all down: rotors, pads, calipers, lines, and fluids. What they actually do, what the differences are, and how to choose the right setup for your car. By the end, you'll know exactly what upgrades make the most sense for your ride and what is just marketing. If you like learning about cars and upgrades, hit that subscribe button. This one's going to make your next brake job a lot smarter. How brakes actually work. When you press the pedal, a rod pushes into the master cylinder, forcing brake fluid through hydraulic lines. That pressure moves pistons inside each caliper, pressing brake pads against the spinning rotor. The friction between pad and rotor converts motion into heat, and the system's entire job is managing that heat. Because when brakes don't dissipate the heat like they're intended, they get too hot and begin to fade. Brake fade: what it is and why it happens. Brake fade happens when your system gets so hot that friction drops off dramatically. You press harder on the pedal, but the car just doesn't slow the way it should. There are two main types of fade: pad fade and fluid fade. Pad fade happens when the resin binders in the pad material overheat and release gases. Those gases create a thin boundary layer between the pad and rotor, a cushion of vapor that reduces contact and friction. That's why slotted or drilled rotors were originally invented, to let that gas escape. Fluid fade is different. It happens when the brake fluid itself boils. When that happens, gas bubbles form inside the lines. And since gas compresses, your pedal suddenly feels soft or spongy. You might still have brakes, but they're weak and inconsistent until the system cools down. Both kinds of fade are caused by heat, and both can be prevented with proper materials and maintenance. High-temp pads, quality rotors that dissipate heat efficiently, and fresh brake fluid with a high boiling point, like DOT4 or DOT 5.1. For hard driving, airflow is everything. Vented rotors, ducting, and cooling channels can also make a massive difference. Brake rotors: design, construction, and coatings. The rotor is the disc your pads clamp onto, and it's one of the most visible parts of your braking system. Let's start with designs. Plain rotors are what most cars come with. They're quiet, inexpensive, and perfectly fine for daily driving. Drilled rotors have holes that vent gas and water, great in wet conditions or for early pad materials that outgassed heavily. But those holes can also create stress points. Run them hard enough, and they can crack. Slotted rotors have shallow grooves that continually clean the pad surface and let gases escape. They maintain consistent bite under repeated hard stops. That's why they're common on performance cars and track builds. Drilled and slotted rotors look cool and can help vent gas. But the real benefit is mostly aesthetic for street cars. Now let's talk construction. Most rotors are cast iron, which handles heat well and provides consistent friction. Higher-end setups, like you'll find on exotics or serious track cars, use carbon ceramic rotors. They're incredibly light, resist fade at extreme temps, and can last hundreds of track hours, but they also cost thousands of dollars. Many aftermarket performance kits use two-piece rotors with aluminum hats bolted to iron rings. That reduces unsprung weight, the mass that moves with your wheel, which helps suspension response and cooling. And coatings? They matter more than you'd think. Bare cast iron rusts quickly, so most modern rotors have a zinc or geomet coating to protect non-contact surfaces from corrosion. Some are even painted black or silver for looks. Coated edges don't change braking performance, but they keep the hub area clean and professional looking. If you've ever seen blue spots or surface cracks after hard driving, that's heat stress. Those hot spots are uneven material changes from overheating. They can cause vibration, noise, and inconsistent pedal feel, all signs the rotor's cooked. So, for most drivers, blank or slotted rotors are ideal. For track or heavy towing, vented and slotted rotors are best. and for high-end performance. Two-piece or carbon ceramic if your budget allows. Calipers, 1, 2, 4, or 6 pistons. Calipers are what turn hydraulic pressure into clamping force. A single piston floating caliper, the kind on most daily drivers, pushes the pad from one side and slides to apply even pressure. Simple and effective. A 4-piston fixed caliper, like a typical Brembo setup, uses pistons on both sides, giving quicker, more even engagement. 6-piston calipers are used on high-performance and heavy vehicles. They spread the load across a larger pad area, handle more heat, and deliver consistent bite lap after lap. But here's the catch. More pistons don't automatically mean shorter stops. They mainly improve modulation, the ability to finely control brake pressure at the edge of traction. Good modulation gives you a predictable pedal, especially under hard braking. In racing and performance systems, calipers are designed for precision and heat resistance. You'll see monoblock calipers machined from a single piece of aluminum for stiffness and minimal flex. You'll also find quick-change pads and floating rotors that allow expansion without warping under heat. For daily driving, fixed calipers can improve feel, but floating calipers work just fine, and they're cheaper to maintain. Brake pads, ceramic, semi-metallic, and organic. Pads are where friction happens, and they have the biggest impact on how your brakes feel and sound. Ceramic pads are quiet, low dust, and long-lasting. They perform consistently across temperature ranges and are gentle on rotors, ideal for daily use and commuters. Semi-metallic pads mix in metal fibers for better heat transfer and friction. They bite harder, stay consistent under high heat, and recover quickly from fade. That's why they're used on police cars, tow trucks, and track vehicles. They can squeak more and generate darker dust, but that's the trade-off for performance. That squeal isn't always a problem. It's the pad vibrating at high frequency against the rotor surface. Semi-metallics are more prone to it because metal conducts sound and reacts sharply to microscopic imperfections. Ceramics dampen vibration naturally, but they have slightly less cold bite. Organic or NAO pads are softer and smoother, good for lighter cars and older vehicles, but prone to fade under heat. Performance and race pads are a whole different level. Carbon Kevlar or sintered metal compounds built for extreme temperatures. They can be noisy and dusty, but they deliver unmatched consistency when hot. Just don't use them on the street. They need heat to work, and cold stops will feel terrible. So for the street, ceramic or semi-metallic. For track or heavy use, semi-metallic or race compounds. And remember, the best pad is the one designed for your heat range, not someone else's driving style. Brake lines and pedal feel. Brake lines don't get much attention, but they're critical to how the pedal feels. Most factory cars use rubber lines. They're flexible, cheap, and absorb vibration. But they can also expand slightly under pressure. That expansion makes the pedal feel soft or mushy, especially under heavy braking. Stainless braided lines solve that. They wrap the inner hose in a steel braid that prevents swelling, giving you a firmer, more direct pedal feel. They don't make your car stop faster, but they make the brakes feel sharper and more responsive. While we're here, it's worth mentioning brake bleeding, removing air from the system. Even a small bubble in the line can compress under pressure, creating a soft pedal. If you're installing new lines, always bleed the system completely. And start with the caliper farthest from the master cylinder. For street cars, fresh fluid and healthy rubber lines are fine. For performance builds, braided lines and high-temp fluid give a noticeable upgrade in consistency and feedback. Brake fluid, DOT 3, 4, 5, and 5.1. Brake fluid transfers every ounce of pedal force through the system, and its boiling point decides how much heat it can handle before fading. This is measured in dry and wet boiling points. Dry boiling point is when the fluid begins to boil in its purest form, before it's absorbed any moisture. Wet boiling point is when the fluid begins to boil after it's absorbed some moisture, usually 3.7% by volume. The U.S. Department of Transportation then classifies these boiling point ranges based on a DOT number. So yes, DOT is the acronym for Department of Transportation. The most common DOT ratings are DOT 3, 4, 5, and 5.1. There are also some LV or low viscosity products out there. DOT 3 is standard for most vehicles. It's affordable and effective but absorbs moisture over time. DOT4 has higher dry and wet boiling points, making it ideal for spirited driving or mountain terrain. DOT5 is silicone-based, doesn't absorb water, but can't be mixed with other types and isn't suitable for ABS. DOT 5.1 is glycol-based like 3 and 4, but with higher performance limits. Perfect for track use or sustained high heat. If you daily drive, 3 or 4 is fine. If you drive hard, tow, or track your car, use 4 or 5.1. And whatever you choose, flush it every 1 to 2 years to maintain performance. Putting it all together, here's how to match everything to your driving style. Daily driver, ceramic pads, blank or slotted rotors, DOT 3 or 4 fluid, and standard rubber lines. Your ride's brakes will be affordable, quiet, clean, and reliable. Weekend canyon or track car, semi-metallic or race pads, slotted rotors, DOT 4 or 5.1 fluid, stainless braided lines, and 4 or 6 piston fixed calipers from Brembo, StopTech, or Willwood. You'll deal with more noise and nastier dust, but you'll have incredible consistency and brakes you can trust, barreling into the end of straight turn at 140 miles per hour. Towing or heavy vehicle, semi-metallic pads, vented slotted rotors, DOT 4 fluid, and larger multi-piston calipers. You'll have steady performance under load with fade resistance. Show or street cruiser, drilled and slotted rotors for looks, ceramic pads for low dust, and DOT 4 fluid for reliability. All the visual appeal without compromising safety. Brake myths and mistakes. Let's clear up a few myths that just won't die. Myth 1. Warped rotors. Most warped rotors aren't warped at all. They've just developed uneven pad deposits. That thin layer of pad material creates a high spot, causing pulsation or vibration. A proper bed-in usually fixes it. If not, try turning them at a local auto parts store before replacing. Myth 2. Drilled rotors stop faster. They don't. They look sporty and help with gas venting, but actual stopping distance comes from pad friction and tire grip. Myth 3. More pistons mean more stopping power. Not necessarily. They improve feel and heat management, but your tire's grip is the real limiting factor. Myth 4. Cheap pads are just as good. They're not. Inconsistent compounds and poor heat tolerance lead to faster wear and longer stopping distances. Myth 5. Mixing pad compounds is fine. Different friction levels front and rear can upset balance and trigger ABS early. Always match compound types across axles. And the biggest one, upgrading your brakes doesn't automatically shorten your stops. What it does is make stopping consistent, lap after lap, hill after hill, year after year. Better braking isn't about spending more. It's about spending smart. Choose the right parts for how you drive. Keep your system maintained, and you'll have confidence every time you hit the pedal. If this helped you understand your brakes, hit like and subscribe for more real-world car education. No hype, no gimmicks, just the facts that make you a smarter driver. Drive safe, wrench smart, and I'll see you in the next one.